let's do our big boy pants on and actually try hard today. I've been liking tries tries. The tries are kind of fun, but at the same time, kind of a pain. Okay, I think I get the gist of this. I'm probably not gonna be able to solve this. To be fair, 37% GG's in the chat, but we'll see. We'll see. Let's see if I can solve it. I know the basic idea. Given a bank of words, find all the words you can find in the board. So I'm definitely gonna need a. This is definitely a try problem. I know it's try. First things first, I'm probably gonna convert the words into a list, or actually a set, so it's constant lookup. Second thing is, how do I want to traverse and stop? I have an idea. Actually, no. Okay, I think this is easier than I'm thinking. Instead of making a words into a set, I should try every word and see if they're in the board. So here's the general plan. General plan. So the general plan is, okay, go through the word bank, try to find the word in the word bank, in the word bank, I guess in the board, possibly DFS. If detected, add to list, return list. That sounds like a high level plan, but this is hard for a reason. So there might be a better way to do this. What is this? Oath and eat. The same letter cell may not be used more than once. Okay. Return words must be constructed from letters of sequentially adjacent cells where adjacent cells are horizontally. So no diagonals. I can only go up, down, left, right. Okay. Can only go left, right, down, up. Okay. Okay. What else can I do? Okay, I'm trying to see how a try would be helpful here. What if I could generate all the paths? That would be a lot of memory, but let's see the constraint here. Like from O, where can I go? I can go to, yeah, I should probably do, yeah. What if I convert the board into a kind of try tree? So like, convert the board into a try tree, right? So for example, we have here O A O A T O A. I can't go T actually. No, I can't go to T. I can go to E. That's it. Okay, this is nice. This is nice. And then I'll just traverse basically go through the word and then go through the tree. Of course, starting with the letter. Is there any duplicate letters? Uh, words of I. Okay, let's see. All strings of the words are unique. Fair. I don't think that matters. That's no. I don't think it matters. Cause I can start anywhere. Like I can start like this guy's word is not starting from the edge. So yeah, I can do it. I could go to like for every single board or every single letter is a source starting point and where you can like visit. I can go here and here. So that was relatively small then. I can't really not really. I have to rethink this. From A I can go to T. Obviously I can go to O again. Okay. Like if I can detect it all around, okay. The problem is I don't know if I've seen it. Okay. The index is probably very important. So I probably gotta keep track of the index, like 0, 0. When I do a certain path, my God, this might be pretty. This tree might be huge, but I think I'm gonna try it. I think it's worth it to try. So I'm gonna basically build out this entire tree. That's a lot of compute, and then I would have to once I finish the tree, um, yeah, yeah. Then I go through the words. Okay, that's my idea. It doesn't sound like a terrible plan. It might be. The problem is building a tree. I don't know how very simple it is. The thing is like, I feel like if I build the tree, isn't that like a waste of time? Like the board could be huge, you know? Like I'm trying to generate all the possible. Yeah, I feel like I might TLE. Maybe okay, there's a problem with that. If I build the entire tree, I think that's the only way to be honest. See, backtrack and try. Okay. So like try here. If I build this tree, I feel like this is gonna be like insanely huge. Like I can have that. I can have just this. Like all the. I could have this. Um. Let's just try it. I honestly, this probably is gonna TLE to be honest, but I don't care. It'll be worth a shot. Okay, so how do I convert this to a try tree? Maybe I can create a class try tree. We'll just do tree here is try tree. And and then maybe we could create a class try node. Def root, or actually next we have this self.val. We'll say none for now, right? Or we'll have this here. We'll call this children instead. And then, yeah, we'll just say this is a self.root. Or try node. Default should be none. Yeah. Okay, so we have the try tree, try node, right? And then we can iterate through the board. Okay, so we'll do def DFS, or we can do like a def build tree. We just need to pass in a board, and then a tree dot find words. Pretty simple. I think that's a relatively smart way to organize things. So we'll do pass def find words. Okay. So how do we do this? So build tree will so for every R in row, for every C in R, or for every character in R. Okay. Right. I have to do a very recursive, like, this is gonna probably be the worst part of the algorithm. I don't know, bruh. So like, okay, I can go here, 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 here. I probably should have a set. How do I do this, bro? This is so hard. Maybe I'll just call like a def DFS. Man, this is gonna be bad. Okay, I guess we can do find words and put in the words here. And then put words here. This is gonna be really bad, bro. Man. Do I need to basically call DFS on basically costs DFS on this. On the character. So it does character. If... Nah, bro, that's too much, bro. I have to do it inside the tier. I think it's better to do it here because I have access to the indexes and stuff. Okay, I have to do it this way. I in range of length of... Let's be clean here. We'll do n equals length of board. M for this. Yep, and we'll do n. We'll do C R. In range of n. Okay. Source is board of R C, and then that's why I want this like helper DFS, you know. And then we'll do scene with RC ready, and then DFS on the source and scene. And the board, I guess. So def, we'll do... no, I can't do that. That doesn't make sense. I should put, how do I do this, bro? This is so bad. Okay, I can probably just do all here. So okay. I wish I could do it a little recursively. I guess we'll create a stack too. We'll do iterative while stack. Put the source here. Nah, I'm not putting the board. Let's put R. Okay, while source. Okay, while stack. Self.root. We definitely need to keep track of the root. Okay. Okay, yeah, and do basically go just as far as you can. Stack.pop. Call this a node, and create a tree node. So create tree. New node. Or this is what am I doing here? So I get a tuple. So tree node, right? I need to put Okay, I got it now. So cur dot children is going to be that new node. Okay, so this is the start. So new node. Let's call this a tree node instead. And then we'll put in the characters. So that's just board of RC. Right, board of RC. Yep. Nope, that's not. So board of put this after the tree node. Okay, tree node, and then we put okay, what do I do here? Tree node is equal to node of 0 and character is equal to node of 0. I should unpack this. What am I doing, bro? Because I need to use it anyways. Row call board of row call, and then tree node with that. Then yep, and then we okay, first check if out of bounds. If row less, if min of row call less than 0, or row is greater than n, or greater than equal to n, or call greater than equal to m. Continue. Yeah, out of bounds check. Then create the new node. Then move the pointer equals I should definitely do this here instead. I'll do this here. And I'll do this. Right. I don't know. Okay, cur is equal to cur dot children of tree node, and that we've moved on to the next level. Does that even make sense? I move on to the next one. I don't remember how this works. So it's cur dot children. I don't even need to do that, right? I just do tree node, right? Right, there's already a pointer cur.children, right? So I'm saying the root.children is putting the tree node as the key and then the value. Yep, okay. Then then I want to try so we want to try row plus stack.append row -1 with C, so downwards. We also want to add going upwards, which is +1. We also want to go so we go up, so down, up. We gotta do okay. This is gonna be tricky. So we do this is called, what am I doing? So row plus minus a plus, going right ways, right ways. Dude, yeah, this is actually really bad. There's so many different ways. Like, it's not even necessary to go through all of it. Like, I feel I can optimize it by just limiting my search to... Yeah, hold on. Let's scrap this, guys. Scrap this, scrap this, scrap this, scrap this, scrap this. Scrap this whole idea. Why even look at the whole board? We can limit ourselves to this, like the words. Why can't I just do screw this try stuff. You know, screw all of this. Actually, reset this. I'm realizing my plan is so shit. Okay. Like, I'm actually trying to do all the combinations in the world. That's way too much time. Okay, we know the constraint. It's just like we just care about how big the words are, right? So like we can just, why can't I just do some basic simulation? Like, all right, for every word in words, for every character in yeah, so for every of a 0 equals character start, and then we'll do start the search because it's potentially a thing here. Like, I potentially could be DFS here, I guess. I don't know. Okay, I have a better idea. We should use a tree to check the existence of the word. So let's do this. We'll build a tree. And if we find the character in the, right? So we'll do this. For row in range of length of board. Call in range of length of board of 0. If board of row, call in try. Yeah, then we'll do something. Then yeah, like if we find a character, go in our try. So let me implement the try first. For every word in words, for every character in word, try of character. If try, we'll do cur here. If try in, or if character not in cur of character equals this, and then cur of character equals cur is this. And after each word, then we'll say cur of equals. Okay, we finished the word, so I need to. Right now, I'm pointing at a dictionary, so I should do. So at the end of the word, maybe I can just put. Like. Equals the actual word. So like once they hit the $sign, then we know the actual word, and we can just append the word here. So let me print try. What am I doing here? JSON. This one starts crying because it's. Okay. So what we have here is a stinking crazy set of things here. Oh, that makes sense. I probably should reset the cur equals try again. Does that make a difference? I don't think it did. Ah, there you go. That's what I wanted. I wanted each level to be different. Like I wanted every single thing to be a level. Okay. Then, okay, so basically, I have the tree now. Right, I have the root of the tree, or the try. Now, okay, if you're in the tree, then you have a potential chance to go through here. And if you make it to the end, that's really good. But I have to explore all paths, so we have to do like a DFS. Probably take a source. We'll just say R column, and yeah, that's good enough for me, I guess. So I want to try going here, here. Yeah, so basically, try all the directions. So DFS R +1. So that's going down. That. -1. +1. That's going to the right. It's going to the left. And at any point, so I should check now. If you're out of bounds, that's the most important. So min of RC. Return. If row +1, or if row greater than or equal to length of board, or C greater than or equal to length of board. Return. And if R is less than, or not S, less than, if, yeah, we're good. Return. So these are out of bounds. Now check if the current, okay, I should pass on the level I'm on. So level, I'll just pass in. So we'll call DFS, the row, call, and try. So the level is, okay, so if, so character is just basically board of RC. Then, okay, if character in level, let's say we'll just be negative. If not in level, then also return. And let's say you are, then that's really good. Well, level is going to be in character, right? So we'll reassign that. And we'll call these guys with that. Also, let's say you're a happy case. If $ in level, then return return the level at this, right? And if I get anything none, then that's bad. Okay. So we move on. Yep. And basically word, if word, res.append word. How does that look? Okay, so pretty straightforward. Um, I just prune it if I'm not even in that level. I only move on if yeah, I only move on if I only move on if the character is in the level. This should work. I see the vision here. Let me add this a set. I feel like I'm gonna add the word too many times. So set. And let's do this. There's a chance that I might like, oops. Let's do a res, convert this to a list. Okay, let's try it. Oh, okay, it actually ran, but, you know. Interesting. Interesting. Okay. We actually got it running, so there was no errors, but there's a problem. Am I running this correctly? Maybe this will help us. All right, so we are doing that. That's really good. Okay, seems like we are like traversing correctly. Interesting. Maybe it's because I'm adding it wrong. Print word. Wow, we're not getting anything. Probably check print board of R. Interesting. So we are traversing, but we're just not traversing correctly. So O and E. Oh. Maybe I'm pruning too fast? Oath, and eat. That's good. That's really good. We should be traversing only those. Okay, I'm not returning correctly. That's probably why. Let me see something. Print. Bruh. Okay. Bruh. So I'm actually... Hold on. One of the levels... Hello. Hello. Oh, I'm actually returning none. Am I doing it too early? When is this one here? I feel like I'm close. What am I missing? Huh. Print level. Kind of stumped here, not gonna lie. What am I missing, dude? Or I'll just do this into a... Dude, this sucks, man. I'm so close. I don't know why I'm messing up right now. Okay, so why is this here? This is wrong. Still wrong, man. Like, okay, for example, I can be going here and I'll go down here, right? That's their return out. Then we check here. That's not gonna be the next one, but it's gonna be minus one. We'll check here. That's out of bounds, so it returns out. Then you'll do the plus one. That's actually in the thing, so we actually will call. Oh no, I want to try again. Like I want to try. Oh, do I just give up as soon as I fail? So I return here. Oh, no. I need to keep trying. This might be more backtracking then. I'm not doing backtracking properly. So I think I give up here. I should have kept going. But the thing is, I'm seeing all the paths though. So... Like I'm gonna wait. So I did, okay, so the first call, I'm here. Try to go down, not valid. Then I try to go left, or not left, up, not valid. Then I try to go here. Then that's valid. So all of these are fine. We move the thing here. Should I move the level up? Should I do this instead? Okay, I feel like I'm doing something wrong here. So like, okay, in the level I call it on is here. Yes. Then I move the level. So I move down level, and then I should basically only move towards like A, I guess, right? And all of these will fail except for this one, and all of these are good, right? Then I'll move to A level, which could be all of these right here, right? Or here, the only valid one is T. So from A, I need to keep going. So I try to go up, that fails. Then I try to go left, that fails. Then I go try to go down, that's fine. Nope, we don't do that yet. Oh, actually, we do go down. Wait, +1 actually, yeah, it does fine. So we go here again. Now, we're actually traversing fine, I think. Do we really need a backtrack? I don't understand the backtracking. Like, for example, we found O. We try to go up. That fails. Or actually goes, that fails here. Then we try to go left or down. That fails. We try to go right. That does succeed. So we'll go here. We're still on this call. Then we move on. Then we try to go up. That actually does work. So we go again. Right? Then I try to go up again. And it fails. But from here, I should still continue. I should try to go to the right. No. Oh, I mean, not right. I should go up, down. That works. So, wait. I should probably have it visited. Visited.add character. Not character, tuple. If RC and visited. Okay. Maybe that will help. I'm like so close. I need to see a solution. Would they have? They seem to be backtracking, I guess. Why though? Let me see again. Let me try to rethink my logic. Hold on. So that means our try is going to be at the level we want it to be. So if actually we don't even need to do this, right? We don't even need to do this. So if we've made it to the farthest we can, I don't even need this, bro. Right? If try, so basically, crap, no, that's not right. Just return the try, or the level, right? If this in level, then res.add level of, yeah. How does that work? Is that, do we actually add stuff? No, still? What is happening? I'm not getting any words added. Still none, 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 none. Oh, I seem like I'm getting earlier. Okay, let's do this instead. Frick this thing. I feel like I'm really close. Visit is not defined. Nothing, bro. Dude. You know what I realized? I never keep track of the word. Like, okay, first off, if in level return I've never like out of all these calls potentially we could have something. So I need to return that, you know? So I should return. Okay, I'm actually gonna call this like this more. Like for every DRDC in directions is just equal to we'll do plus so 1 0 minus 1 0 then 0 1 then 0 negative 1, right? Then something can return from the DFS call, right? So it's R plus DR plus C plus DC. If word, then return that. Because as soon as I find one, I want to tell the... I want to tell... I want to tell... yeah, I want to tell them that I found something because the calls could be from this, but I would never really return it. I just discard it as soon as I find a valid one. Okay, I messed up a level. Just give it to me. Oh my god, finally, bro. Please, bro, just don't be too slow. Of course I get the wrong answer. Use test case. Why is this wrong? I just only got OA and then there's OAA. Ooh, shit. Oh, I just stop. No, why would I do that? Why would I think it's because I stop or something? I definitely gotta see the tree for this one. Okay, the problem here is I just stop at the the earliest level. I should just like continue searching, no? Maybe I could just add it to the res.add and then just keep going. Yeah, just like add all the words you can find. Yeah. Screw this. Just go as deep as you can. Like, why even stop? Like that's just a potential word. Okay, a lot better. No way ideally, bro. No wonder it's a freaking hard, bro. Oh, I got a wrong answer. Interesting. Wait, that's kind of weird. What is this? There's only two things here, and the tree should be just A, and then the word is A. Then I go here, right? If so, there should only be one. Yeah, there should only be one. There's no even point to do this. DFS will handle that. Oh, I see. I do every direction and there. Oh, that's why I need to visit it. Okay, I'll do a visit. Let's do scene. If R C in scene, return. Okay, we validated. Scene dot add character. RC. And then we'll just create it every time we start a new search. And then we'll add that here. Still nothing. Kind of wild. Okay, what if I'll just like allow it again or something. That is so annoying, bro. I've tried so many times. I don't know why. What is the solution? They seems to like be removing stuff again. End of exploration. So okay, I'll do it that way too then. I'll alter the board. Okay, mark the cell as visited. Scene.add. Okay, I'll do it actually here. Oh, that's why. Okay, let me use it. Then mark it. If I haven't used it, then why even do that? Then move to the next level, then enumerate. Or yeah. Bro, it's still broken. Why? I don't understand why. feel like I'm so close, bro. This was like, there's always some weird like stuff that I haven't seen. Okay, yeah, we've detected that we just add him to the thing because we want to keep going. RC, if it's in the scene, then don't even explore further. If you're out of bounds, then we check the character, check if the character's in the level. If it's not, then get out of there. Now it's a new letter we've seen, then move to the character. Then from there, move on and create a new set. No, we need to use the scene, same set. Come on, gang. Okay, finally, that's exactly what I was looking for. Bro, this stupid freaking problem. I got oath, eat, HF. I'm missing a word. Are you dead ass? Oh, I have to hold on. Let me see. Not discard the R. I gotta allow it to be. I gotta. Oh no! What? This messes up this. Ooh, okay. Maybe do it after. Okay, a lot better. Still. Oh my god, I'm so done with this, bro. No way I got a time limit exceeded. Is this really this slow? Bro, I'm just one test case away. Come on, bro. What is an optimization I can do? I'm only trying. Okay, what is the optimization they do? They seem like they do that. Optimization incrementally remove the match leak from the try. I don't get that. Check if we find the match of a word, as well as avoiding using a set for result. Oh, maybe we should probably do that. Also, we remove the match fit to avoid results. We remove the match word to avoid duplicates. Okay, it's my set calls. Maybe we do something else. I guess the try. Okay, I guess we can use the current level we're on. Okay. I guess we'll do, okay. Current. No. I'll do the checking here after that. Okay, we have the character and the level, and then check also. No, I'll do it here. I'll do it right here. So, okay, now check if there's a word match. Right. So level dot pop pop remove it. Why do we remove? I don't want to remove it though. We also remove the match word to avoid duplicates. Oh, okay. Fair. Okay, that's actually pretty fair actually. pop this, then word, just return false if it's that, and then if word match, okay, and I actually will just have to do this, turn res, word match dot or res dot append word. So we actually remove it so we don't actually like duplicate it, right? Okay, and if the character is not in the level, then we also exit out early. Then we add ourselves to the thing, move on to the next level, go through all of it, and then remove ourselves again, so we can explore other paths again. Just give it to me, bro. Oh, we got a wrong answer this time. Okay, that sucks balls. Is this TLE or what? Oh, we also removed the letter. Wouldn't that mess up like... Wouldn't that like mess up a lot of things? Let's try it. So after we've... Okay, after the for loop, if not level, parent. Ooh, okay, parent. If not, what is cur node? The actual letter. If not character, then level dot pop letter. So letter, what is letter? I don't know what letter is. Oh, letter is the actual character. Okay, so the character. And then this is something else. I have no idea what this is actually. If not kernel, pair.pop. The character, if not what though? Oh, the current node, which is, ooh, that's why we should, okay. And then we'll put, yeah, that makes sense, okay. If not cur node, then level.pop character. Alternate increment, move the max, leaving the tree. I feel like that's gonna break everything though. What? What is this doing? We got nothing but expected an A. Why? Nope, nope, nope. Yes. Res.pend A. Why is this failing, bro? It actually doesn't do that. That's interesting. Let me just check this print. Try. Yeah. Let me check print. So print level. So we're actually should be on the A level. What do I make curve node actually? I do it here. Am I supposed to do it earlier? He does it way earlier. Oh, that's why. It's because I do it different. Okay. Let me just do that then. And I'll do it from here as well. Dude, I'm like so close, but now I'm like just copying the answer at this point because it's just. What? Oh yeah, I gotta make sure that fucking character exists. I'll do this. Key error E. No, don't do this yet. Yeah, I'll do this here. Wait, isn't that the same thing? Just give it to me, bro. Finally. That took so long. Alright, you guys.